Buti ma'am, I'm Liza FB from BSA 2. So, ngayon po, iti-discuss ko po yung ibinigay nyo pong 8 problems kung paano ko po ito na-solve po. So, number 1 problem. If each of the three nails shown on the figure below has a diameter of 4 mm and can withstand our average shear stress of 6 MPa, so determine the maximal allowable force P that can be applied to the board. So, ito po yung given. Number of nail, NA is equals 3. So, diameter of each nail, D equals 4 mm. And average shear stress on the nails, phi equals 60 MPa. So, the average shear stress on the nails is given by pi equals P over NA. So, here, P is the maximum allowable force on the board and A is the cross-sectional area of each nail. So, sinolve ko na po ito para maiksi na rin, at hindi na rin po ako mahirapan sa pag-solve po. So, pi equals P over nx pi over 4 d2. So, P pi times n times pi over 4 d2. So, ito po, P equals 60 times 10, 6, n over 2x 3 times pi over 4 times 4 mm times 1 meter over 1,000 millimeter 2. So, sinolve po natin, PS equals 2,621.947 Newton. So, P equals 2.262 kilonewton. So, therefore, the maximum allowable force is 2.262 kilonewton. So, number 2 problems, if the L-boat is made of a material having a yield stress of 250 MPa, determine the minimum required diameter of each sharks. Apply a factor of safety 1.5 against yielding. So, ito po yung given. So, given is yield stress is 250 MPa and factor of safety is 1.5. So, i-determine natin yung the allowable shear stress. So, allowable equals allowable Y over Fs. So allowable force equals 250 over 1.5 equals 166.667 MPa. And apply equilibrium equation. So, Fx equals 0. So, Na negative 30 equals 0. And N equals 30 kilonewton. So, allowable force equals F over A. So, 166.667 times 10, 6 equals 30 times 10 raised to 3 over pi over 4 times d2. So, d2 equals 30 times 10 raised to 3 over pi over 4 times 166.67 times 10 raised to 6. So, d2 equals 2.2918 times 4 raised to negative 4, and d equals square root of 2.2918 times 10 raised to negative 4, and d equals 0.015138 m. And ito po yung final answer is d equals 15.14 mm po. So, yun po yung solving ng number 2. So, proceed po tayo sa number 3. If the bolt of the supporting bracket shown in the figure are made of the same material having a failure shear stress of 120 MPa, determine the maximum allowable force that can be applied to the bolt so that it does not pull through the plates. Apply a factor of safety 2.5 against shear failures. So, ito po yung given niya. Shear stress failure is equals 120 MPa and factor of safety is 2.5. So, pi safety equals allowable nails over IF point S equals 120 over 2.5 equals 48 MPa. So, pi equals P over pi D1. So, equals P, P po ito, over pi, pi times 4 times 75. So, pi safe equals 48 MPa equals P over 9,428. So, P point 4 452.1160 kilonewton. So, we note that ito po yung V, ito naman po yung pababa, yung P. So, pi equals P over pi dl. So, P equals ay over pi 80 times 30. Pi safe equals P. Sinove natin yan, yung P over 7,536 millimeter ay 2. 48 times 10 raised to negative 6 equals P over 7,536 millimeter raised to 2. So, there the maximum allowable force equals P equals 361.728 kilonewtons. So, yun po yung number 3 problems. So, ito naman po yung number 4 problems. Determine the required diameter of the pins at A and B to the nearest 1 over 16 in if the allowable stress for the materials is 6 KIS, KSI. Pin A is subjected to double shears where pin B is subjected to single shears. So, ito po yung given natin. So, the given is diameter A and B is yun yung hinahanap natin, and B, yun din yung hinahanap natin. So, allowable stress allows 6 KSI. So, double band B and single band B naman. So, ito po is yung, ano tawag dito? Ito po yung BD. So, MA equals 0 by 12 minus 3 times 3x 8 equals 0. So, by 2 KIP. Dito naman, Vx equals 0J and negative 3 plus EX equals 0. So, EX equals 3 KIP. So, dito naman, yung Fy, yung Fy natin equals 0J and by the By plus AY equals 0. So, AY is equals to KIP. So VA natin equals 1 over 2 square root of AX raised to 2 plus AY2. So, equals 1 over 2 square root of 2 raised to 2 plus 3 raised to 2 equals 1.8 KIP. So, sabi naman natin, VB equals square root of 4 raised to 2 plus 3 raised to 2 equals 5 KIP. So, dito naman, 6 equals 1.5 over pi dA2 over 4. So, dA equals 0.61814 in. So, pi equals VB over pi over 4 dB2 raised to 2. So, the dV, ito naman dA, ito naman sagot sa dV. So, the dV equals 1.061 in. So, ito po yung number 4 problems. So, sa number 5 naman, a spherical gas tank has an inner radius of 1.5 m if the subjected to an internal pressure of 300 kip. Determine the required tank thickness of the maximum normal stress is not to exceed 12 MPa. So, ito po yung given natin, the inner radius of spherical tank is R equals 1.5 m, and internal pressure in spherical tank is P equals 300 kPa, and maximum normal stress is allowable equals 12 MPa. The expression of the required thickness. So allowable equals Pxr over 2xt. So T equals Pxr and over 2px allowable. So here T is the required thickness. So T equals 300 kPa times 1.5 m, and over 2 times 12 MPa times 1000 kPa over 1 MPa. So T equals 0.01875 m times 1000 millimeter over 1 meter. So the T is equals 18.75 millimeter. So ito po yung final answer natin sa number 5 problem. So proceed tayo sa number 6 problem. So pressurized spherical tank is made of 0.5 in tank steel if it is the subjected to an internal pressure of 200 psi. Determine its outer radius if this maximum normal stress is not to exceed 12 MPa. So ito po yung given natin. Thickness of pressurized spherical tank T equals 0.5 in, and internal pressure P equals 200 psi. So maximum normal stress equals allow equals 15 ksi. So allow equals Pxr over 2T. So 15 times 103 equals 200 R over 2 times 0.5 equals R equals 7.5 in plus 0.5 in. So the R is equals 75.5 in. So ito po yung final answer natin in number 6. So number 7, air pressure in the cylinder is increased by existing force 2 kN on the two pistons, each having a radius of 45 mm. If the cylinder has a wall thickness of 2 mm, determine the stress in the wall of the cylinder. So, ito po yung given natin. The given is air pressure in the cylinder P equals 2 kilonewtons, and radius of each piston is R equals 45 millimeters, and cylinder wall thickness is T equals 2 millimeters. So the pressure is P equals F over A, and ito po equals 2 times uh, 10 raised to 3 Newton over negative pi times 45 raised to 2 millimeter raised to 2. So the P is equals 0.314 MPa. So state of stress is allowable M equals PR over T. So equals 0.314 times 45 over 2. So equals allowable 7.073 MPa. So longitude stress is allowable to equals PR over T, I2T equals 0.314 times 45 over 2x, I2x2. So allowable L equals 3.5 3.536 MPa. So ito po yung sagot natin sa number 7 problem. So proceed tayo sa number 8 problem. The A36 steel band shown below in 2N wide and is secured around the smooth rigged cylinder. If the bolts are tightened, so the tension in the team of 400 lb determine the normal stress in the band and the pressure exerted on the cylinder. So ito po yung given natin. Tension is F equals for COLB. So thickness is T equals 1 over 5 in and width is 2n and ito po yung may A hanggang C siya. So radial stress allowable R equals F over A and equals 400 2x 1 over 8 times 1. So the allowable R equals 1,600 psi. So letter B, of stress is allowable N equals PR over T. So 1,600 equals Px 8 over uh, 1 over 8. So P equals 25 PST. So letter C, stain change in length or original length. Change in length on allowable and over E times pi or mean. So equals 1,600 over 29 times 10 raised to 6 times pi 8 plus 1 over 16. So equals 1.3975 times 10 raised to negative 3n. So ito po yung sagot natin, ang final answer natin sa number 8 problem. So that's all po.